good day to all. My name is Brian Pewty, and I play the character of Bacon Mug in the series of intermittently running and moderately humorous opening sections of lesson videos sent to your homes each and every day. It takes time and energy to produce this level of marginally successful entertainment, particularly on the part of our writer-director, who finds himself completely out of any new ideas this week. Have I got that right? So, in light of that sudden absence of creativity, he's asked me to step in and act as a sort of substitute, as it were, and he's even told me that I can discuss whatever topic I like, which will make a nice change from playing the rather cold and calculating misanthrope that I do, and instead give me the chance to talk about my only true passion in life, my extensive collection of snow globes. Such as this snow globe, with its fearful ninja assassin, or this snow globe, which brings back memories of the needless Y2K scare at the turn of the millennium, or this snow globe, which features a minion from the delightful Despicable Me series of motion pictures. You know, the history of snow globes is a fascinating one, and it's a topic about which I would gladly go on for hours and hours. It all began in the late 19th century with visionary Austrian inventor Erwin Percy, who...
No. Stop that. I can only apologize. I tried to come up with something better for today, and we all do our best. I hope you can forgive me until next week. And now for something completely different. So to get right to the point, I want to keep the video very short today. We're going to cover the last of the pieces that you're going to see on your quiz on Tuesday. So Monday, you're going to have two assignments. One is not going to be related to math at all, and the other one is just going to be an opportunity for you to review. It will not be for a grade. So I want to let you know when you look over those items, which will include what we're going to talk about today, and don't let this daunt you. I want you to come to live conferences on Tuesday if you have questions before you take the quiz. So just make sure you take advantage of that. So now that we've worked with the product rule, the quotient rule, and the power rule, now we're going to use those rules to help us both expand and condense logarithms. And don't worry, I wrote them all in advance so I wouldn't have to waste your time by writing. And if this is daunting to you at all, just follow me through this. There's three things you want to keep your eye on. One, are things being multiplied, in which case we're going to apply the product rule? Are they being divided, in which case we're going to apply the quotient rule? And are they being raised to a power, in which case we're going to apply the power rule? And the basic rule of thumb with expanding logarithms, and again, at the end of this chapter, we'll get to why you would do this in the first place, then you know you've broken everything down. So we'll look at this first one and I'll show you kind of how we can find our way. So we have the log base 7 of three discrete elements. We have a coefficient, an x variable, and a y variable. That's 49 times x cubed times, and don't let this get to you, the fifth root of y squared. So the first thing you should be thinking to yourself is, okay, the product rule means I can expand this and add all these together. And that's what we've done here. Log base 7 of 49 plus log base 7 of x cubed plus log base 7 of y to the 2/5 power. Hopefully everybody gets how I did that. It was squared under the radical. That was the fifth root, so we can turn that into a fraction. We've practiced with that a lot. So we've got the first big step done. Nothing else is being multiplied. Nothing else is being divided. So we're either going to be able to derive the actual value of a log, or we're going to deal with these two exponents. And the general rule of thumb with variables is this, guys. You know you're close to the end of the expansion if your variables don't have any exponents. If they do, you still probably need to apply the power rule. So what is log base 7 of 49? Well, that's 2. 7 to the second power, 7 squared is 49. And then for the remaining two, we're just going to use the power rule to move the exponent to the front of each log. So we end up with 2 plus 3 log base 7 of x plus 2/5 times log base 7 of y. I know that seems like a cumbersome answer, but it basically lets us know that we've broken this down into all its component parts. Let's look at this next one. We have the natural log, remember that's base e, of x squared minus 4 over 9 times e times x to the third power. E raised to the x to the third power. Don't let that trip you up, either my misspeaking or what's actually going on there. So the first thing hopefully everybody can recognize is we've got a difference of squares there. We can break it down into its component binomial factors. So we've done that right here. I just turned x squared minus 4 into x minus 2 times x plus 2. Left the denominator completely alone. Next, and we can do this in any order, but this is really the simplest way to do it. Let's deal with this fraction first. So we know the quotient rule means it's whatever's on top minus whatever's on the bottom. So hopefully everybody can see that's what I've done right here. Here's the numerator of that natural log minus, that's our quotient rule, the denominator of that natural log. Now within that, hopefully you can see that there are still things being multiplied here. So I can use the product rule there. So I added these two together using the product rule. And then remember, you keep this in parentheses because we're going to distribute this negative. I use the product rule on these two. Natural log of 9 and natural log of e raised to the x to the third power. Now, the vast majority of these, you can't do anything with them. Can't do anything with this, we're done. Can't do anything with this, we're done. We distribute that negative through. Can't do anything with natural log of 9, but remember that cancellation rule. A general rule with cancellation is, if you have any log where the base of that log is also the value which we're applying the log to, in this case e, with a base of e, remember like yesterday's homework, we can eliminate all of that. So that leaves us with natural log of x minus 2 plus natural log of x plus 2 minus the log of 9. Can't do anything with those three, but we can use cancellation to turn this into x to the third. Quick dissolve, and we're going to take a look at how we go in the other direction, how we condense. Okay, so now, how do we condense? So we basically just look for the same hallmarks to apply those three rules, product, quotient, and power, and we just try to want to do it in an orderly fashion, generally working from left to right, or when we have parentheses that we can deal with, dealing with those. So let's look at this first one. We have 1/2 log of x minus 1. Don't freak out that there's no base here. Remember, that just means it's our common base of 10. Doesn't mean anything in this case. Minus 3 times the log of z plus the log of 5. So hopefully when you look at this, you can see since we have these coefficients at the front, you should be thinking, okay, I'm going to start with the power rule here. It's an easy way to clean this stuff up. And so that's what we've done here. Log of x minus 1 raised to the 1/2 power minus log of z cubed, because we've moved that 3 to the exponent position, and then log of 5, we can't do anything with that. So now we've gotten rid of all of our coefficients. We know there's no more power rule to use. So now we're just going to deal with these plus and minus signs, which basically just mean a series of product and quotient rules. So generally working from left to right is a good thing to do. So since we have this one minus this one, let's turn that into a fraction using the quotient rule, which we've done right here. Log of x minus 1 raised to the 1/2 over z to the third. Just use the quotient rule on these two, picking away at it a piece at a time, plus log of 5. Now, we don't have any coefficients, right? We've done everything we can with this part. We still have this plus sign, which basically just means we're going to move this 5 and multiply it by everything that we have here using the product rule. So that 5 is going to go up in the numerator, and we're going to end with log of 5 times x minus 1 raised to the 1/2 power over z cubed. Again, that's confusing. Back up and look at it again and just see that we worked from left to right, dealing with certain rules that allow us to move forward in an orderly fashion. Let's take a look at this one. Anytime you see something in parentheses that you can work with, you should go ahead and do that. So 1/3 times, all in parentheses, log base 3 of x minus 2 log base 3 of y, close parentheses there, plus log base 3 of 10. Hopefully by now, you're getting the sense of this. You're looking there and you're going, okay, there's something inside the parentheses I can apply the power rule to, which we've done. It's the only change we've made in this first part. Again, still in parentheses, 2 logs being subtracted. So you should think to yourself, okay, that's our quotient rule. So that's what we've done here. Left the 1/3 alone, simply took the x and the y squared and applied the quotient rule to turn them into a fraction. Left the log base 3 of 10 alone. Now that we're done with all our parentheses, just work from left to right. First thing you should see here is, a spot where we can apply the power rule, which we've done. Just took this 1/3 and made it the exponent of this fraction. Log base 3, x over y squared, raised to the 1/3 power, and still log base 3 of 10 just sitting over here waiting for something to do, which it now does. Done with this part, added to this part, we can now apply the power rule, so we are just going to multiply everything through. Log base 3 of, and this is in brackets, because remember, this is the only part that's being raised to the 1/3 power, so we need to keep it separate. For those of you wondering, well, can we just put that in the numerator? Not because of this parenthetical. Log base 3 of 10 times x over y squared raised to the 1/3 power. So again, when we expand, we're going to look at opportunities to implement the product and the quotient and the power rule in one direction. And when we condense, we're just going to reverse that process. Use the discussion board today. If you have questions, contact me directly. Remember, Monday will be entirely review. So use that for your own knowledge. Monday's assignment will not be for a grade. It's just there for you to find your legs. And then on Tuesday, we'll have the quiz. Make sure you come and see me in live conference if you have any questions. I hope everybody has a wonderful weekend, and I will see you on Monday.
Not to mention the transition and technological advancement, including moving away from fragile glass dome structures to more hardy and advanced polyurethane and acrylic domes, all of which I will tell you about in great detail right now.